Let's solve for moment gradient, C sub B. Determine the moment gradient, C sub B, of a beam with a length of 6 meters. Okay, so I'll draw a beam with a length of 6 meters. Okay, simply supported daw siya. Yan. Tapos, having a uniform load. So, uniform load. Okay. So, hindi na sinabi kung service load. It doesn't matter in this case, no? So, 60 kilonewton per meter. Again, the length is 6 meters. Okay. Ang equation sa 6th edition, if you recall, write it down here. So, C sub B, 6th edition po ito ha. So, hindi ito yung natutunan previously. So, 12.5 mmax over the quantity 2.5, the maximum moment, plus 3 times moment A, excuse me, plus 4 times m sub B, plus 3 times m sub C. Okay, yung explanation niya nandun sa unang video presentation ko, no? So, nakahiwalay. So, ang sabi pa rin dito, simply supported a W shape with lateral support at its end only. So, ibig sabihin, may lateral support lang siya dito. Okay? So, meron lang siyang support. Reaction support to, may lateral support din siya at both ends lang. So, ano bang CB nung pinag-aralan natin previously? Ang CB niya kapag ganyan, uniform load, if you recall, balikan niyo yung previous lecture ko, ang CB niya dapat is 1.14. So, I have to prove, or we will prove, no, na ang CB is 1.14. Okay, itong style ng ginagawa ko, maraming way para computein yung moment maximum, moment at A, moment at B, at moment at C. Ang ginagawa ko ganito. Okay, there are several ways in doing this, but this is how I solve this, no? Depende kung anong klaseng, anong method ang gusto nyo. Ang gagawin ko muna, solving ko muna yung reactions. But kahit anong method, solving mo din yung reactions, okay? So, I'll call this A and B. So, ano yung reaction at A? Okay. It's 60 times 6 divided by 2 or 60 times 3. So, this will be 180 kilonewton. Okay. So, RB, kahit di na natin pakita yan, 180 kilonewton. Pero pinakita ko na rin. Okay. Ang style na ginagawa ko is yung parang method ng double integration method. Okay. Kukunin ko na rin yung shear. Okay. So, ang ginagawa ko dyan, I usually cut katulad ng double integration, cut almost near to the support, and I'll give this a value of x. Okay? So, pag ganyan ang ginawa natin, isahan natin sa shear. Okay, so parang ganito. Kinat lang natin yan. Cut ko to. Tapos, ito yung distance na x. Okay? And this is 60 kilonewton per meter. Okay, ilan to? 180. So, pag shear ang kukunin natin, so ito yun, di ba, pababa, V. Okay, dito naman yung moment. So, kapag moment naman ang pag-uusapan, ganun din, cut mo rin sa, halos sa dulo, almost approaching at the end of the length. Moment naman, ito yung moment, and then, parang pares lang talaga, no? Kaya lang, ang hinahanap dito, moment. Okay, so this is also 60 kilonewton per meter. And approaching this length. Okay? So this is also 180 kilonewton. Unahin muna natin yung shear. So this will be moment. So at any point, no, yung katulad ng double integration, the value of shear will be equal to 180 plus kasi pataas minus 60 times x. Diba? At any point yan. Dito naman, ang moment dito, at any point, will be 180 times x minus, kasi pababa yan, diba? rotate ko dyan sa moment. Equilibrium, hindi, it's not the exact word that I'm looking for. So, moment ka dito at this point. So, this is 60 times x. Ang centroid niya is x over 2. Okay? Unahin muna natin yung moment. Explain ko na lang a little while yung sa shear. So, ang sabi kasi sa equation, if you recall this one, the location of MA is what? It's the absolute value of moment at quarter points. So, divide mo ng 4, no? Quarter points. M sub B, absolute value of moment at midpoint sa gitna. Okay? And CU, third quarter. Okay? So, umpisahan natin. So, para mabilis lang, no? Ganun ang ginagawa ko. So, at any point. So, in distance in meter. So, gagawin ko lang dito. Ito yung moment. Okay? Ang sabi, quarter points. Ano ba yung 6 divided by 4? Diba? Quarter, di-divide mo ng 4. And total length is 6. Divide mo ng 4, that will be 1.5. Ano yung midway ng 6? 3 meters. O, yung 3 quarters. So, divide mo ng 4 times 1 ng 3, it's 4.5. So, ganun na lang. Diba? Mabilis. Ito yung moment at A, moment at B, and moment at C. Kaya ganito ang ginagawa kong style. If you have another method, then so be it. Basta parehas ang lalabas. So, lalabas ko lang to. Yung 1.5, ilalagay ko lang sa value ng x. Ito yung value ng x. So, 180 times 1.5 minus 60 times 1.5 squared divided by 2 and will give me a value of 202.5. Ito, inject ko lang yung 3 dun sa value ng x. Ang lalabas is 270. Okay? Ang unit is kilonewton meter. So, ito din, 4.5. Ang value ngayon yan ay ilan? Yes, the same, 2.2.5. Pero meron pa kasi tayong solving dito, Mmax. Okay, ano yung definition uli ng Mmax? It's the absolute value of maximum moment. Okay, absolute value, maximum moment within the unbraced length. Okay, ito yung unbraced length natin. No? Ito yung unbraced natin from 0 to 6. Ano daw yung maximum moment at that point? Well, obviously, nasa ano din, no? Nasa 270. Diba? Kasi ano ba yung ano natin? Tinuro sa mechanics of deformable bodies. Dito, kaya nilagay ito. When shear, the value of shear is equal to 0, then the moment is maximum. So, alamin muna natin to. So, this will be 0, 180 minus 60 times x. So, ano yung value ng x? Parang 180 divided by 60, that would be 3 meters. So, ito rin yun. So, this is also equal to Mmax. Nagkataon, no? Na yan ang Mmax. Kasi pinapatunayan lang natin, ang value dapat ng CB, base sa previous lecture natin, it's equal to 1.14. Okay? So, patunayan lang natin. So, lalagay lang natin ulit dito, CB. Ang equation is 12.5. Ano yung Mmax? 270. Yan. Equation sa taas. Equal to or all over 2.5 times 270 Mmax plus 3 times Ma. Excuse me, 202.5 plus 4 times Mb, which is also equal to Mmax plus 3 times MC. Ang MC is equal to also 202.5. So, ang CB is equal to approximately 1. Ilan na ba yun? 1.14. So, this is our final answer for CB.